Guys, this is the excavation. The excavation is finished. It's about 6 meter depth, and this is the adjacent building. As you can see here, the excavation is 1 meter below the 1 meter below the footing of the adjacent building, and we have here the pit, the elevation pit, and we have some support to the adjacent building so that it won't collapse. You can see here, and this is the cesspool, and this is the support for the adjacent building. So because it has no basement, this is the basement of the adjacent building. Hey, what's up guys? In this tutorial I'm going to talk about the RAFT foundation. This is a RAFT foundation, and as you can see, the bottom mesh is ready, and as you can see here, the diameter of the bar is 20 millimeters in both direction. We have the bottom reinforcement, both directions, short and long direction. Okay, so we have the spacing here. The spacing here is 15 centimeter by 15 centimeter. Okay, 15 by 15, and we have the cover. The cover of the reinforcement is about 6 centimeter. 6 centimeter. Okay. So we have the additional bar under the column here. We have a column here, as you can see, it's marked here. So we have additional bar in a long direction. This is, this is long direction, and this is long direction. This direction, and this one is short direction. Okay, and this is okay. We have additional bar in under the column in long direction only. In the long direction, I guess the length is by 3 meter in the long direction. Okay, not in both direction, in long direction only. So I thought, okay, we have the columns. This is the edge column, the marginal column. We have the this is 45 centimeter. Okay, and we have the shear wall, retaining wall here. This is retaining wall, 560 millimeter. Okay, we have also 45. Okay, so and let's go and look at the other side. Here we also have additional in long direction only, and as you can see here, there's a fatal mistake here. The lap splice, they put the lap slides under the column, which is it's a red flag. It's the biggest mistake ever. Okay, it's a fatal mistake. You never put lap splice under the column, because we have the greatest moment under the columns. All right. So we have here, the guys, and as you can see here, there's another fatal mistake, which is the septic tank. This is the bottom. It's like a septic tank. You can say it's a pit, but it's there's no submersible pump in it. You just they just drill a hole, in in the foundation level, and they put the these cylinders, several cylinders inside. It's like 10 meters deep, and there are holes in the cylinders to dissipate the water into the bottom of the foundation, which is the biggest mistake ever. You never put water under your foundation, which is it causes settlement in the future within time. So they put the lap splice. Okay, also they put lap splice here. As you can see here, we have lap splice here. Okay, all in one line, which is not recommended by codes. Okay, so we have in the long direction, we have lap splice here. We have the cover. They put 5 centimeter. We have lean concrete, and we have the cover for 5 centimeter, and which is not, which also is recommended to have 7 centimeter instead of 5 if you have contact with the soil. So we have another fatal mistake, which is there's no cover between the rebars, the footing or rebar, the foundation rebars, and the soil. You see that we have contact, direct contact with the soil, which is leads to future. Gradually it'll corrode. All the bars will corrode. Big problem. Okay, we have a person here. Okay, so we have here. Hey guys, this is the Raft Foundation. Almost the top network is almost finished. The chairs being laid out, and as you can see here, you see the chairs, you know, to separate the bottom and top layers. We have chairs like that, you know, see that? Okay, so we have the mechanical systems almost ready. You see that? And this is the top layer. This is a top reinforcement. Half is finished, half is remained. So we have here, but I don't. This is weird because I have additional rebar on the top of the column. That's weird. Here also I have additional rebar on the top of the. On what I mean by top of the column, I mean by the top reinforcement. You know, top layers. The top network, I have additional rebar. That's weird. I never seen that before. I don't know who designed this raft foundation. Who's the designer? I don't know. Only I know the guy, the architect. I just knew him on the site. I introduced myself to him, but I never seen additional rebar on the column, and that's very weird. Because we only have additional rebar on the bottom mesh, on the column location, on top of the column bottom mesh, not the top mesh, bottom mesh on the columns. You know, you can see here. That's weird. I'm gonna go down and show you more. In the design of raft, or in the design of the slab, we design the moment by number of bars per meter. How? Because we divide the slab with 1 meter strips in both directions and design the slab by number of bars per meter. So here in this raft foundation I have 7 bars per meter, and so the spacing would be 1/6, which is equal to 16 centimeters center to center of the bar. Thank you guys. I'm on the raft foundation, the top reinforcement. As you can see here, the bottom is finished, the top almost finished, the half is finished. Here is your top reinforcement. This part is both directions finished. This part is only one direction is finished. We have the lap splice here also on the short direction lap splice. We have here the chairs. As you can see, this is the chair. This is the chair. This is the legs. The legs almost 50 or 60 centimeter. Okay. This is the chair. So I have the chairs. I have the cord. This is the cord to hold the other additional rebars. You see, this is the cord holding those bars. Okay, on the top of the chair. Okay, this is the chair. Okay, this is the cord to hold the reinforcement only. It has no job, only but holding the reinforcement in short direction. Okay. So we have the main rebar, the main direction of the reinforcement in long direction. See that in the long direction, and the top reinforcement also will be the same. It will be the mirror. It will be the mirror of the bottom mesh. Okay. So we have the cord also. Okay. They used, I guess they used a 25 millimeter, if I'm not mistaken. Yeah, 25 millimeter the cord is, and the chair is 60 centimeter. This leg, 60 centimeter, and the back is also 50 centimeter. Okay, the back of the chair. Let's go look at this one. See that the back is 50 centimeter. And the legs are 60 centimeter, which is okay. And the spacing is, as you can see here, the spacing between the cord, as I told you before, the cord this is the cord holding the top mesh. Okay, only holding the top mesh. The spacing between this cord and the next one is 150, which is a lot. It should be 1 meter, but this is 150. Okay, this one is from the chair, the back of the chair. Okay, this one. So this one is 140. Okay, that's another note I told you. The sewage system or the mechanical system, the sanitary or the drain system. So as you can see here, the pipe's been skewered with these bars, with this structure, and they welded the structure to the reinforcement. But there's another mistake, which is this reinforcement is directly has contact with this the concrete or the lean concrete, which should has a cover at least, not contact with the concrete. Okay. So it's going to this septic tank, as I told you previously. And this bar is also, we have here skewed, and this bar is going up. Maybe it's for cleaning. I guess it's for cleaning, if I'm not mistaken. I'm gonna ask the guy later. Okay, this is the place of the lift pit. Okay, you can see that. It's from this level, it should be 150. 1.5 meter below this level. Okay, okay, so this is the standard. It is okay, so obviously they are doing some expansion because they didn't they made mistake. It's obvious. So this is the mechanical system, the sewage system. It's going from here and it's connecting to this one. It's going to that this pit that I told you before. It has no submersible pump. Guys, this is the chair, okay, that I told you before. It's one leg is, the legs are resting on the bottom mesh. Okay, both legs are resting on the bottom mesh. For the note that I'm going to tell you, this is the development length. So all bars that two different parts, which is when they are connecting, it should have the top should has a development length with the other part. For example, here we have this bar, which is it should be a retaining wall, or you can see it's going to be a retaining wall. And this one, the development length should be 65 diameter. Okay, 65 or 60 diameter of the bar should start from here till the footing. Okay, till there. So you calculate, you measure from here 65 or 60 diameter of the bar. When it should read from here till there. For example, if it's 1 meter, it should read from here to with the leg, okay, including the legs. Okay, so guys, the thickness of the raft is obviously is 60 centimeter. Okay, this is 60 centimeter because it's only about 7 or 8 centimeters left to the cover. Okay, raft thickness is 60 centimeters. So the development length start from here. For example, in the column, the development length start from the top of the footing or the raft. From here, you can say here. Okay, it's measured the 65 or 60 diameter of the bar, 60 diameter of this bar, and it should measure from here, and it will be inserted to that component, which is this here. For example, here this raft. So it should be 65 of the diameter. Okay, minimum. Guys, another mistake here. The development length of this of the column, it should be 65 or 60 diameter of the bar. 60 diameter. This bar is 20 millimeter. Okay, so as you can see here, this is 20 millimeter. Okay, so if you multiply 20 by 60, it will be 120 or 1.2 meter. Okay, so as I measured from here, the lap length from here, this is 40. Okay, plus 40 is 80. They only use 80 centimeter. Okay, we have only 80 centimeter, which is much less than 1.2 meter. Okay, so that's another mistake, a fatal mistake, because this is the footing, this is a foundation, this column, and it's holding all the weights, most of the weight of the building. Okay, thank you. Guys, another mistake, and I just noticed, is there's no additional bar under the marginal column. No additional bar whatsoever. Okay, on both on this marginal, on the edge column, we have edge column, there's no additional bar whatsoever. Okay, thank you. In another angle, I'm just showing you the top and bottom reinforcement and the chairs and the cord. Okay, in another angle, as you can see here, we have 60 centimeter raft. Okay, mechanical system here, right? And the spacing, the cover. Okay, this is the cover, 5 centimeter cover. Okay, I showed you multiple mistakes in this raft, and thank you very much for watching.